You're welcome today. This evening we will be looking at how we can balance redox reactions in alkaline medium. In one of our previous videos I have explained how we can balance redox reactions in acidic medium. I gave the number of steps and I used a question to solve it in a practical way. So I'm going to do the same thing now. Just like I explained in that video, a redox reaction is a reaction that involves both oxidation and reduction. So all we have to do to balance this redox reaction in alkaline medium is to follow the steps. The step 1 is that we are going to identify and write the oxidation half equation and the reduction half equation. Then the second thing is that we are going to balance the atoms, that is the reaction, the equation. We are going to balance the left hand side and the right hand side. We are going to balance all the atoms just like our regular normal equation, but we are going to neglect the atoms of hydrogen and oxygen. Then thirdly is that apart from balancing the reaction, neglecting that of hydrogen and oxygen, we are going to, for excess oxygen in any of the sides, we are going to add a water molecule to the same side. Then on the other side, we are going to balance with 2 hydroxyl ion. Then after that, we are going to balance our charges, because after introducing water molecule and hydroxyl ion, we would have been able to balance all the atoms. So the next thing left for us will be to balance the charges and then to sum up the equation so as to get our overall redox reaction in what? Alkaline medium. So let's take it one by one. Step 1. My step 1. So for my step 1, like I said, I'm going to identify and write out the oxidation half equation and reduction half equation. So how do I get to know that? The same way, I'll come to this place. If I want to get the oxidation number of manganese here, all I have to do is write this out. So I have MnO4 minus. My Mn, let me represent it as X, plus 4 into, oxygen has an oxidation number of -2. So I'm going to write my -2 is equal to what? -1. Then I'll have X, plus times minus is minus, 2 times 4 is 8, is equal to -1. So X is going to be -1 plus 8. So X is equal to plus 7. That implies that the oxidation number of manganese in this ion is what? Plus 7. And we know that our oxygen is always -2 except in peroxides. This is not a peroxide, so I'm going to write it out as -2. So this is -2. And then for water molecule, the hydrogen here, I need to know the oxidation number, okay? So I have 2, because I have 2 atoms of hydrogen, so that will be 2 into, let's say, X, plus the oxidation number of oxygen is always -2, so that's -2 equal to, there is no charge here, so it's going to be equal to 0. So that will be 2x minus 2 equal to 0. That will be 2x is equal to 2. Then x is going to give me, that will be all over 2, all over 2. 2 will cancel out 2, so x is going to give me plus 1. So that means the oxidation number of hydrogen here is plus 1, while oxygen is -2. For sulfur, I have my SO3 2 minus. Let's say I'm representing my sulfur with X, then 3 into, oxygen is -2. So I have -2 is equal to, the net charge is -2. So that will be X, plus times minus is minus, 2 times 3 is going to give me 6, which is equal to -2. So X is equal to -2 plus 6, then X is equal to plus 4. So I'm going to write it out as plus 4. My oxygen is always what? -2. Then I will move on to manganese here. My manganese is what? X plus 2 into, I have -2 equal to 0. There is no net charge, so that's 0. So that will be X minus 4 equal to 0. Then X is equal to plus 4. Oxidation number of manganese here is plus 4. Oxygen is always -2. Oxygen is -2. Then hydrogen here, I have -2 plus X is equal to -1. The next charge here is -1. Okay, so that's X is equal to minus 1 plus 2. Minus 1 plus 2 is going to give me 1, so that is 1. Oxidation number of hydrogen here is plus 1. Sulfur, SO4 2 minus. This is X plus 4 into minus 2 equal to minus 2. So my 4 plus 4 multiplied by minus 2 is going to give me minus 8. So I have X minus 8 is equal to minus 2. Then X is equal to minus 2 plus 8, which is equal to plus 6. So that implies that the oxidation number of sulfur in this is going to be what? Plus 6. And I know that my oxygen is always minus 2. Okay? Now, all I have to do now is to identify where I have my oxidation and reduction. Now, the oxidation number of manganese in MnO4 minus is plus 7 here, but it is now plus 4. It is now plus 4. So that implies that there is a decrease in oxidation number. And one of the definitions I gave for reduction is that reduction is what? Decrease in oxidation number, while oxidation is what? Increase in oxidation number. So that means that from this to this, I'm going to have my reduction, while for this to this, I will have my oxidation. I'll have my oxidation. Look at, oxygen is minus 2, minus 2. Plus 1, plus 1. So I've got nothing to do with the hydroxyl ion and the water molecule there. So this is what I have. So I can easily write out my oxidation half equation and reduction half equation. So for my, I have MnO4 minus going to MnO2. This represents my reduction half equation, while SO3 2 minus going to SO4 2 minus represents my oxidation half equation. So now I'm done with step 1. I can move on to step 2. So for my step 2, all I have to do is to balance what? Balance the atoms except those of hydrogen and oxygen. Now, if I look, let me bring it out. I have MnO4 minus, then MnO2. My manganese, as I have one atom of manganese here, one atom of manganese. I am not concerned with oxygen, so I'll move on to this. I have SO3 2 minus going to SO4 2 minus. Now, I have an atom of sulfur here, one atom of sulfur here. So I have nothing to do with oxygen, so I'm going to proceed. So that implies that I'm done with step 2. Now for step 3. For my step 3, what I'm going to do, according to what I said earlier, you can go back to the video to listen again. I said that for every side that has excess oxygen, we are going to add a water molecule to the same side. So let me first start with this equation. I have MnO4 minus going to MnO2. Now, I have 2 excess oxygen molecules, and the rule is that for an extra oxygen atom, I will add a water molecule to the same side and 2 hydroxyl ion to the other side. But here I have 2 additional oxygen atoms. If I compare these 2 sides, this one has got 2 atoms of oxygen, this has 4 atoms of oxygen. So what I'm going to do now is to add 2 water molecules here. So I will have MnO4 minus plus 2H2O. Then instead of adding 2 hydroxyl ions to the other side, it becomes 4 because I have 2 extra oxygen atoms there. Okay, so that will be MnO2 plus 4OH minus plus 4OH minus. Now if we look at this by visual inspection, an atom of manganese on the left hand side, an atom of manganese on the right hand side. I have 4 atoms of oxygen plus 2 here, that makes it 6. On the other side, I have 2 atoms of oxygen plus 4 here, that makes it 6. Manganese is balanced, oxygen is balanced. For hydrogen, I have 2 times 2, that's 4 atoms of hydrogen. I also have 4 atoms of hydrogen on the right hand side. So that implies that I've been able to balance the atoms, including the added one, that's water molecule and what? Hydroxy ion. So I can easily move on to the other equation. So I have SO3 2 minus going to SO4 2 minus. Now I have an extra oxygen atom on the right hand side. So what am I going to do? I'll add a water molecule to the right hand side, then to the left hand side I will add what? 2 hydroxyl ion, because what I have is an excess oxygen on the right hand side. So I'm going to have 2 OH minus, then SO4 2 minus plus a water molecule. Now by visual inspection, I have an atom of sulfur, an atom of sulfur. I have 3 atoms of oxygen plus 2 here, that makes it 5. Then on the other side I have 4 oxygen, 1, that makes it 5. Oxygen is balanced, sulfur is balanced. Then for hydrogen, I have 2 atoms of hydrogen, 2 atoms of hydrogen. That implies that I've been able to balance these 2 half equations in terms of the number of what? Atoms. The next thing I have to do is balance the charges. That's my step 4. So I'm going to rub this off to continue. So for my step 4, I have, let me start with this first equation. I have MnO4 minus plus 2H2O going to MnO2 plus 4OH minus. I want to deal with the charges this time around, not the atoms. I'm dealing with the what? The charges. MnO4 minus means I have a minus 1 here, minus 1. So the charge on this side is minus 1 plus, if I look at this, there is no charge. So that means it is automatically 0. So minus 1 plus 0 is going to give me minus 1 on the left hand side. On the right hand side, I have no charge here. So that makes it what? 0 plus, I have minus 4. So that would be minus 4. So that would be 0 minus 4, which is simply minus 4. So I have a charge of minus 1 here, and I have a charge of minus 4. I said earlier that I am going to balance the charges with what? Electrons. And don't forget that electrons carry negative charge. Okay, if I have an electron, that means I have minus 1. So if I bring minus 1 here, minus 1 minus 1 is going to be what? Minus 2. So how many electrons do I need to make this minus 4? All I need is what? 3. Because by the time I have minus 1, minus 3, I'm going to have minus 4 on the left hand side and minus 4 on the right hand side. So that's what I'm going for now. So I'm going to have MnO4 minus plus 2H2O plus 3 electrons and MnO2 plus 4OH minus. So with this, I've been able to balance what? The charges. The atoms are balanced, the charges are balanced. Minus 1 plus minus 1 minus 3, that's minus 4, and I have minus 4 here. So I'll go for the other equation, which is SO3 2 minus plus 2OH minus going to SO4 2 minus plus H2O. Now by visual inspection, I have minus 2 here, minus 2, that will be minus 2 plus another minus 2. So that will be minus 2 minus 2, which is what? Minus 4. So the left hand side, the next charge is what? Minus 4. Let me go to the right hand side. All I have here is minus 2 plus 0. That's going to be what? Minus 2. By visual inspection, if I come here and I add 2 electrons, because electrons carry negative charge, if I add 2, that will be minus 2 minus 2, that makes it minus 4. So all I have to do to balance this side is to add what? Plus 2 electrons. Okay? So I'm going to add, I'm simply going to add 2 electrons here. And that makes it what? Balanced. So the next thing I'm going to do is to look for a way to make the number of electrons here and here to be what? Equal. And that's very simple. From our basic maths knowledge, I will multiply this equation by 2. And I will multiply this equation by what? By 3. 2 multiplied by this is going to give me 2mnO4 minus plus 2 times 2, that's 4H2O, then plus 2 times 3 is at 6E minus, going to 2 times this is what? 2mnO2 plus 2 times 4 is going to give me 8OH minus. So this is straightforward. So I'm going to do the same thing for the next equation, which is 3 times this is what? 3SO3 2 minus plus 6OH minus, going to 3SO4 2 minus plus 3H2O plus 3 times 2 is what? 6P minus. So I'm going to my last step. I'm going to my what? Last step. Now, looking at this, all I have to do is add all the stuffs on the left hand side. Let them stay on the left hand side. And whatever I have for the right hand side, let it be on the right hand side. So, let's look at this together. I have 2mnO4 minus plus 4H2O plus 6E minus. Then it's going to be plus 3SO3 2 minus plus 6OH minus. So the next thing is to go for what I have on the right hand side. Now I'll be going to, I have 2mnO2 plus 8OH minus plus 3SO4 2 minus plus 3H2O, what else do I have? Then plus finally 6E minus. So 6E minus, that's the electrons, can easily cancel out this. I will have to look at things that are similar again. I have 4 molecules of water, I have 3 molecules of water. So the 3 molecules of water here can cancel out 3 molecules of water here, leaving me with a molecule of water here. Is that okay? I have 6 hydroxyl ion on the left hand side, I have 8 on the right hand side. So if 6 comes into 6, I will have 2OH minus left. Do I have any other similar thing? No. So I'm going to put this reaction together. So I have my 2mnO4 minus, this is out, plus 3SO3 2 minus, this is also out, then plus a water molecule. So these are all the things I have on the left hand side now. So I'll move on to the right hand side, which is what? I have 2mnO2, then plus 3SO4 2 minus, plus my 2OH here, 2OH minus. So this is the balanced equation in what? Alkaline medium. Now, I have to do another check to be sure that what I've done is what's correct. So let me check. I'm going to check the atoms and the charges. I'm going to check the atoms and the charges. So on the left hand side, I have manganese, oxygen, and sulfur with hydrogen. I have manganese, sulfur, oxygen, and hydrogen. That's for the number of atoms. Then on the right hand side, I have manganese, sulfur, oxygen, and hydrogen. I have 2 atoms of manganese here by visual inspection. So I have 2. Sulfur, I have 3 atoms of sulfur. For oxygen, I have 2 times 4, that's 8. 8 plus 3 times 3, that's 9. 8 plus 9 is 17. 17 plus 1, that makes it what? 18. For hydrogen, I have 2 atoms of hydrogen on the left hand side, so that's simply 2. Now on the right hand side, I have 2 atoms of manganese, which is what? 2. I have 3 atoms of sulfur, that's 3. For oxygen, I have 2 times 2, which is what? 4. 3 times 4 is 12. 12 plus 4 is going to give me what? 16. Then 16 plus 2. That makes it what? 18. For hydrogen, I have 2 atoms of what? Hydrogen. That's 2. So looking at this, 2, 2, 3, 3, 18, 18, 2, 2. That makes it what? Balanced in terms of the number of atoms. So let me go for the charges. On the left hand side, I have 2MnO4 minus. That means I have a net charge of what? Minus 2. Because there are 2 molecules of what? MnO4 in this. So I have minus 2. Okay? Plus. Now I have 3 atoms of SO32 minus. That means I will have 2 times 3. That's minus what? 6. Minus 6. Then for water, plus 0. So that will be minus 2. Plus times minus is what? Minus. Then 6 plus 0. Minus 2 minus 6 is what? Minus 8 on the left hand side. Now on the right hand side, for this I have 0. The net charge here is 0. Because there is no charge. Plus. Now for this I have 3, 2 minus. Now the 2 multiplied by 3, that's 6. So I have minus 6. Okay? Then plus 2OH minus. So this implies that I have 2 molecules of what? OH minus. So that will be minus 2. Minus 2. So I have 0, minus 6. I have minus here. Minus. Okay? Now minus what? 2. Minus 6 minus 2 is going to give me what? Minus 8. So the charges here are equal. So the charges are balanced, the number of atoms are balanced. So this is a very simple way of balancing redox reactions in what? Alkaline medium. So to ensure that you have understood what I've explained, I'm going to give you a question to solve and you can post your answer to me. Then I'll make correction in the next video. Okay? Now let's say we have MnO4 minus plus N2H4 going to MnO2 plus N2. So try to balance this redox reaction in alkaline media. We'll meet in the next class. Thank you for watching.